Your software's running slow. What are some things that you can do to improve its performance? About 20 years ago, I was working for a small game studio in Takapuna in New Zealand. I was asked to write a tracer bullet mechanism that hooked into the projectile calculation. I set to work. A few days later, the lead complained that when the tracers were on the screen, we were losing frames. One of the other developers delved into the code and eventually figured it out. I was copying a calculated value from one place to another to avoid doing a calculation twice. Unfortunately, this place wasn't faster. I still remember the other dev's categorisation of the problem. Reading from the vertex buffer. Performance requires a mindset change first. If you care about something being fast, then you'll want to measure it. The other thing you'll need to keep in front of mind is that no performance trade-off is free. There's always a cost. Today I'm going to talk about 7 strategies to improve the performance of your application. Parallelise. If your application has to do operations that are expensive to calculate, and it has to do a lot of them, but those operations can be calculated or queried independently, then you might be able to get a performance improvement by parallelising your workload. But remember, parallelising only works if there's capacity available. Otherwise, you'll just end up causing timeouts. So the trade-off here is whether you have more idle capacity that can be called on during peak times. You may need to provision some. Batch. If you have an operation that you perform a lot, but which has an overhead or a startup cost associated with it, you could collect calculations or operations together and perform the operation fewer times. This could look like pre-computing some of an algorithm's interim values, or just looking up the data ahead of a batch of operations and only paying the cost of latency once. Latency. One other way of improving latency is to use the concept of data affinity. If you perform operations closer to the data, then you'll pay a smaller latency on lookup. This might look like replicating data between regions or beefing up compute near a data store, performing operations in the backend, or the client, depending on where the constraint on lookup is. This might also mean distributing compute resources closer to end users. Improve the algorithm. Some algorithms have slower or faster versions available. If you're doing an operation like sorting or searching, then you should check the literature. There's a very good chance that a faster variant is available and that given a bit of time and effort, you could replace a slow approach with a faster one. For a database query, this could look like adding an index or more aggressive table layout changes to allow the DB to search more efficiently. Reduced waste, eliminate or hide. If you don't need something, don't do it. Thinking about games again, I was once told that the fastest triangle is the one that you never draw. If you can find ways to eliminate code or data that you don't need to perform a particular slow query or operation, remove it. Unless you're in a security setting where changing or reducing the runtime of an operation leaks data, then just disable or skip the code that you don't need for an operation. Cache. Keeping expensive data handy is a great way of improving performance. There are a lot of trade-offs to caching though. Your cache data may get stale. The first operation is still slow and you need to provision resources for your cache, which means memory, and people forget about this, but your cache lookup isn't free. It actually costs you CPU cycles to look through the data. And depending on your workload, this might mean looking up data from cold memory, which means pipeline stalls. This robs compute from your other expensive operations, so think carefully about it. Measure. One final piece of advice I'll give you is that if you care about performance, then you'll need to measure it objectively. There's no point in choosing an operation you think will be faster if you aren't actually sure it will be an improvement. How do you know for sure? Measure it. Improving a part of your code that does 0.1% of an operation will not improve the time of the operation. You'll need to look at the parts that you spend most of your time on. Usually that's data lookup. Time it, change it, time it again. Has it improved? Good. If it hasn't, that's good too. Try something else. And if this was helpful, please let me know in the comments.